In this video, we will be reviewing the tasks for practice 4, and that is calculating exact percentiles based on a nominal independent variable. You'll recall that nominal independent variables, or nominal variables in general, are categorical in nature and usually have multiple levels, or different groupings that we can identify our sample off of. So in this data set, we have collected data on lung capacities for males and females who are healthy, wheezing, or have COPD. So already we know that healthy people would be on one end of our distribution in terms of their lung capacity being higher, and COPD, or limited or obstructive pulmonary or lung capacity, would be on the lower end of our distribution, with lower values of lung capacity in liters. What we want to know is what percentile each of these following individuals falls under based on their gender and diagnosed health status. So in our data sheet, we'll pop over here. We've got our legend set up. So under our gender column, females are labeled as 1, males are labeled as 2. And then for our health status, 1 is healthy, 2 is wheezing, 3 is COPD. We then have the lung capacities, and then I've listed the 3 individuals that I had put in the practice instructions. So what we want to do is, when we are going to be making calculations based off of a certain characteristic, the best thing that we can do for ourselves is to filter the data. So we can highlight our data labels, add a filter, click somewhere in our data set. We can then go to custom sort, and then identify how we want to sort our data. So I'm going to sort by gender first, and then by health status. Moving values smallest to largest, so for gender, females would be listed first. For health status, the healthy people would be listed first, and then as we get our numbers, or as our numbers get larger, we get less and less healthy, or getting closer to having COPD. So we can click OK, and then you can see that all of my females have now been clumped together all the way to there. And we can see that each health status is also clumped. So we've got a group of 3s, COPD, group of 2s, that's our wheezing category, and our group of 1s, those are our healthy category. And their respective lung capacities are listed. And then underneath them, we can see the males have been pretty much organized the same way. This will help us with our calculations. So we're going to do kind of 2 different percentile calculations, one just based on gender, the other one just based on the health status. So I'm just going to type that in here. We'll say based on gender. Just so I don't mess up my formatting, I'm going to merge and do a wrap text up here. And we can do the same thing for this one. And this one will be based on, based on gender and their health status. So actually might have to merge these 3. There we go. Okay, and so then this gives us a good example of how we can create a percentile just based on 1 categorical identifier or on 2 categorical identifiers. Our calculation, or our formula for finding an exact percentile when we've got continuous type data, again, the best option is to use a COUNTIF function. to get the cumulative frequency at our given raw score of interest. And then we need to know the total sample size. We divide that sample size by the cumulative frequency, multiply by 100, and we get our percentile. In the previous examples, we split those up into columns. If you feel comfortable doing the calculation that way, you can feel free to split up the columns. But I do want to show you guys what it would look like if we kind of mushed all of our formulas together. So to find the cumulative frequency at our raw score, we're going to do a count if function. And then for this one, Jane is a healthy female. Okay. If we're just basing our calculation on gender, however, we only care about where Jane's position is in the females total. So I'm going to click on my data, and I'm going to scroll until I see the end of my female list. Highlight all of that, put a comma, and then I need to list my range. Now in this case, lower numbers mean less lung capacity, so we want all of the values that are at or less than, worse than, Jane's lung capacity. So this would be a less than criteria and a reference to Jane's lung capacity. So that will give us our cumulative frequency of all the values that occur at and below her lung capacity. Then we want to divide that by our sample size, which we can use the count function for. And we're interested in the same range that we highlighted in our count if function, so you can just reference the cell range that you had in your criteria range for the count if function and put it in the count. So that's our sample size, and then we can multiply by 100 to make a percentage. And then we can get her percentile is 84.31, which generally makes sense, right? If she's on the healthy side, she should be closer to the 100th percentile because her lung capacity is greater. Now, if we were categorizing or finding her percentile based on gender and health, this would mean we're only interested in Jane's percentile within healthy females. So our sample changes, but the function stays the same. So we're going to do count if. Our range is healthy females, so those are people who have the data labels 1, 1. So we can highlight that section, comma. Our criteria are still going to be less than her lung capacity. Divide by the sample size, which is, again, just this range here. Multiply by 100. And then we can see what her percentile is within the healthy individuals. So according to this, she's fairly in the average range of healthy people. So you guys can do those same procedures to find out the percentiles for Jose and Janice.